All right, welcome and good afternoon to all of you to take the time out and join us here this afternoon. Just want to cover a couple things real quick before we get started. Start with the antitrust statement. As most of you know, this is not, as associations, we want to make sure that we're not discussing pricing or areas of that would be of concern of antitrust. So we want to make sure that everybody understands that. And if at any point that anybody believes that we're crossing a line when it comes to that kind of a conversation, feel free to let us know to make sure that we all stay in accordance with that. My name is Wayne Menning. I'm with Ohio Concrete, and on behalf of the Illinois Ready Mix Association and Ohio Concrete, we do welcome you in. We have two great speakers today to discuss designing asphalt for heavyweight pavements, Mike Harrell and Mike Ward. Um, we Ohio Concrete appreciates Illinois Ready Mix letting us work together to bring this to Ohio in conjunction with what they've been doing in Illinois. We are looking forward to hearing what both Mikes have to say here. In regards to certificates for PDH professional development hours, we will expect to get them out no later than 7 days from today. So if you haven't received them in 7 days, definitely want to get a hold of the appropriate person that you deal with. You should be muted upon coming in, but if at any point that you find that your mic has been unmuted, please have it muted. Keep it muted so that we don't have interference. And the last, I guess, logistical piece I want to talk about is just questions. If you could type those into the Q&A, which should be at the bottom of your screen, um, that's how we'll handle questions, and we'll handle them at the end. Theron with Illinois Ready Mix will cover those questions with the speakers. So we're going to have the presentations and then answer questions. All right, so without taking any more time, I want to go ahead and introduce Mike Harrell with ARA and let him go ahead and get started. And Mike, I'll let you give whatever detail you want about yourself as you get started on your presentation.
Sounds great, Wayne. Thank you very much. Let me take over control of the presentation mode here. Hopefully everybody can see this. But I want to thank everybody for the time today. I'm pleased to be a part of this presentation and discussion. I know that on the surface it seemed a little bit counterintuitive to be talking about asphalt pavement designs with concrete associations, but I think it's important for everybody to know what a properly designed asphalt pavement looks like for an industrial application. Too often we've heard that there's been, this is the way we've always done it, and a very thin asphalt pavement is specified for an industrial parking lot that ends up failing very quickly if it is built that way. So today we're going to walk through how to properly design a heavy duty parking lot and hope to share some insights on best practices for, if we were going to design an asphalt parking lot, this is what it would look like, and ways for you to identify whether or not one may have been designed properly or not. So who am I and why am I talking to you about asphalt? Well, I'm a consulting engineer with ARA. I've been with them for 18 years and a total of 21 years of experience in pavement engineering, bachelor's and master's from the University of Illinois. And as it says here on the slide, I've been working primarily in pavement design and evaluation projects, along with asset management and some alternative delivery projects. So design builds and public-private partnerships, working all across the country. And I've got some licenses there, but work with others in plenty of other places too. And I will say that while I'm talking about asphalt today, I do design concrete pavements as well. I am material agnostic. I don't believe that there is only one material. That I think that there's an appropriate place and time for all pavement materials, and properly designed, we can make them all work for the intents that they are planned for. So here we go. This is kind of what we're going to talk through today for asphalt pavement designs for industrial parking lots. We're going to go through some design basics, walk through the AASHTO 93 procedure and the website that permits one to actually walk through the design process there. And then we'll talk briefly about some mechanistic design checks that can be done to, I guess, further ensure that the pavement structure is actually being designed properly and is ready for the loading that it's expected to carry during the life that it's expected to provide. So we'll start out with a light duty example. And this is a typical, vehicle parking lot for employees at a facility. And you'll see some screenshots here from the Pave Express program that is available on the web. There's no cost to use it. You can set up a user profile and store projects there if you want to work through them. And you can select different types of designs that you are intending to execute and the locations for them, when you expect to actually finish construction, and what type of project you're actually trying to design. And so here we've selected a light duty parking lot, and the answer comes back immediately saying that a structural pavement design is not necessary for a light duty parking lot. And therefore you don't have to really worry about that. And they're kind of implying that you typically just take whatever light duty lot design you had last time and push that forward. And a lot of times, at least in IDOT, the Bureau of Local Roads guidance would suggest a 3-inch asphalt over 8 inches of aggregate base. What we've seen with industrial lots is that this has been co-opted for those as well. And no one's actually walked through the process of actually designing the heavy duty parking lot for the heavy duty vehicles it's intended to support. And lo and behold, you have a massively under-designed parking lot. So this is what a real industrial parking lot looks like. Trucks everywhere, some of them loaded, some of them empty, but some of them sitting for long periods of time. You may also have garbage trucks that are entering and maneuvering about the facility. And these can be designed with asphalt materials, but the loads on those vehicles do matter. The subgrade support beneath that pavement structure definitely matters. And the drainage profile of that facility definitely matters. So these are things to keep in mind when specifying an asphalt pavement solution for a heavy duty parking lot. So how does the AASHTO 93 procedure work? I would guess that many people are familiar with this. In several states, this design methodology is actually being phased out in favor of a more mechanistic pavement design approach that takes in a lot more site-specific conditions, but it's also a very rigorous process and uses some pretty advanced software to pull those designs off. The AASHTO 93 procedure is still relevant because it's a very straightforward, fairly simple process to come up with a structural pavement design. And by and large, in comparisons in several places, the AASHTO 93 designs are actually very comparable to the ones that you would come up with in the mechanistic approach. So it's not a 100% match, but for the most part, they're pretty comparable. So the AASHTO 93 procedure basically specifies something called a structural number. It's the required structure to support projected loads for the design life of that pavement. Requires you to you compute a required thickness, which is the structural number, and that's reported in inches. And then you assign material layers with appropriate structural layer coefficients, and those structural layer coefficients increase with stiffness of material. So a subgrade soil does not provide you any real structural benefit. an aggregate base provides you with some structural benefit, and a hot mix asphalt layer will present you with more structural support, and therefore the layer coefficients increase with stiffness. This is a very long and beefy equation to solve to get to the either the number of predicted 18 kip equivalent single axle loads that a pavement would provide, or you can reverse engineer it in order to solve for the structural number with the given number of vehicles that are going to hit that facility. This is a rigorous equation for sure, and the Pave Express program actually automates the process of solving that by presenting you with just some places to actually input the conditions for your particular site, and then presents you with that structural number calculation behind the scenes. So what do you start with? You start with trucks. So you know, if you're going to see a certain number of vehicles, you hope that you have a projection on how many vehicles you're going to see during the course of either a day or a week or a year, and you can project those forward for the duration of design life that you're going to have that facility in place, what kind of structural design life you want for that pavement. Typically, concrete is expected to be 20 years plus. You can get that type of structural support from an asphalt pavement as well, where it only would need some maintenance activities. But again, you have to design it properly. So the default truck factor shown here when you enter the software is showing a load equivalency factor of 1 for a semi-truck. And that is a problematic because that is not right. And what it really should look like is if you were to come up with the correct truck factor for an 18,000 or an 80,000 pound loaded truck, it has the combination of axles shown on the left-hand side that can be extracted out of the tables that exist for the load equivalency factors for different axle configurations and loads on those axles. And so what you end up finding is that with an 80,000 pound legal limit loaded truck, that you're actually carrying 2.7 equivalent single axle loads per truck, not just one equivalent single axle load. So a pretty significant difference there. And we'll see how that actually affects the pavement design process here. So when you update the truck factor, as you can see here, now it's showing the appropriate truck factor for those vehicles. We can move forward through the design procedure. So this example is going to highlight a 50 truck per day design example. That can definitely be changed if your facility is expecting to see more or fewer trucks. You can actually work on some blended truck traffic scenarios where if you have different types of trucks and different percentages of your overall traffic stream, that you can update those appropriately. So the next step in the design process is to start from the subgrade and work your way up. So in this case, we have this design example was for Illinois. Most of Illinois is sitting on top of soils that are great for growing crops and are lousy for supporting structures, either roads or buildings. In this case, very typical clay soil modulus or a California bearing ratio of 3 is appropriate, which will translate to somewhere between 4,500 and 5,200 PSI in a resilient modulus based on the type of correlation that you use to move from CBR to resilient modulus. Those are fairly close to one another. It's not actually that critical to choose one model or the other for that correlation. The next step in an asphalt pavement is what's on top of your subgrade. Well, in most cases, that's an aggregate base layer. In this example, we're in Illinois and we're talking about an IDOT CA6 or crushed stone base. It's a very typical crushed aggregate product that is screened and accepted for quality. And the typical AASHTO layer coefficient associated with a high quality aggregate base is this 0.14 that's shown in the layer coefficient box on the screen. And the resilient modulus equivalent of that for that material is roughly 30,000 PSI. There's some range associated with that. And then the thickness information, you can type in a starting thickness, but you can declare it whether or not you want that to be the exact thickness you're going to specify, or if you want the program to help you optimize the thicknesses of the various materials that you're going to select. And you can declare whether or not you would want it to deviate from that seed value of thickness. In our pavement design experience, most site planners would agree that a minimum of 6 inches of stone base is an appropriate way to build a foundation for an asphalt pavement. And there's a couple of primary reasons for that. There's more stiffness in that aggregate, obviously, than the soil that it's sitting on top of. So the stiffness definitely helps support the pavement. It helps with asphalt compaction effort that's coming later. If you can compact against something that's more stiff, you're going to get better density out of that asphalt when you compact it. It also provides a more a long-term, better construction platform, and it definitely helps with site drainage and separation of that subgrade material. So the next phase is to move up from the aggregate, and you're now talking about asphalt material properties. Again, a lot of times the assumption is that you're working with typical state-based highway mixtures that include quality control testing and some pretty significant laboratory control. And the layer coefficients that are typical for those mixtures are shown here on the screen, and they can vary depending on whether or not you're using like an SMA or a polymer modified binder, or there's different reasons to choose different layer coefficients. But by and large, these are the ranges that are typically used for, again, state type mixtures. And we'll walk through some examples here in a minute of why that may or may not be appropriate for an industrial parking lot design. So here's the result of, again, our 50 truck per day example. And you can see it's a lot more than a 3/8 design. So 50 trucks per day for 20 years ended up with a total of 6 inches of asphalt material and 13.5 inches of aggregate base material. So a sizably, substantially increased pavement structure compared to that 3/8 assumption that may have been brought to the table. So this is why it's very important to actually design an asphalt pavement for the truck traffic that is going to be planned for that facility, for the subgrade material properties that are going to be present for that facility. Here's a chart that shows some additional examples that we ran through for 100 trucks per day, 150 trucks per day, 200 trucks per day, and 240 trucks per day, and the number of millions of equivalent single axle loads for a 20-year period, the required structural number for those, and then if you were to limit the asphalt surface layer to just a 2-inch layer, how the asphalt binder and aggregate base layers are increasing to carry those truck traffic projections. And the bottom line here is that you do need a significant structure to carry that level of truck traffic. So what are some typical structures that actually would be present for an industrial parking lot. And we would say in the typical engineering fashion, well, it depends. And really, it depends mostly on the truck traffic loading. And if you have a bank facility, you have deposit trucks and garbage trucks that may be using that facility. Fast food lots include supply trucks and garbage trucks. Schools include buses and garbage trucks and supply trucks for those cafeterias that may be there. Hopefully all of these things will be in full effect in the coming months as vaccinations move out and we start to return to hopefully normal standard business protocols. A quick quiz question for folks to think about: why does summer school matter when you're talking about a school parking lot? Give you a second to think about that. And I didn't put the answer up here on the screen, but the reason is asphalt gets soft in the summertime. So if you were having the same number of loadings taking place for your buses in the summer that you would in the winter, there's significantly more damage done to your parking lot pavement from those summer bus loadings because the material is softer during that time. So if you're going to have a spec design, if you have, you're building a building, there's a facility being built where we don't know who the end tenant is going to be, it's good to design in advance and to think about the potential use of some industrial, heavy vehicles traversing those lots. Theron and I were talking about this, and we kind of keyed in on that. If you're going to not know who your end tenant is, it's really good to plan for, at least 50 trucks a day. That gives you a lot of safety factor on the use of that facility whenever a tenant is going to take it over. You don't have to worry quite as much about that pavement failing on year one and making your facility developer look bad because they didn't plan for the right type of parking lot. And really, it's important as a facility planner to communicate those design assumptions to the tenant when they end up leasing that space. What was intended when the pavement was designed and ultimately built for that spec property? And if the tenant plans to significantly deviate from those design assumptions, then some concessions need to be made on the expectation of how long that pavement is expected to last, or what kind of warranties that developer may pass along to that tenant to ensure that the pavement is in a good working order for their facility. Within the Pave Express tool, you can actually perform what they call a structural analysis. Is also considered a mechanistic design check, where you would actually look at the stresses and strains that are projected or predicted to take place at the critical layer interfaces of that asphalt pavement. And really, you're talking about two main failure modes with asphalt pavements. Those are rutting, and really rutting developing into subgrade material, or fatigue cracking, which is developing starting at the bottom of the asphalt layers and working its way up. Those are very critical kind of real failure distresses that can take place in an asphalt pavement that really require full depth repairs to overcome. Lots of other asphalt distresses are superficial and can be dealt with, either through traditional maintenance activities or even a mill and overlay, but you really want to avoid those full depth failures. And so that's what this process is all about, is if you want to go through the rigor of actually looking at the mechanistic design checks to ensure that the stresses and strains are where they need to be in order to project the loadings are sufficient for that pavement. Again, I was talking about the analysis locations and the desired criteria. So you just specify where the layer interfaces are going to be based on the pavement structure that you're looking to evaluate. This is not one where that's trying to optimize the layers. It's actually looking for you as the designer to input the layer thicknesses and therefore the interface locations for the analysis to take place. And that's it's something that's out there. It doesn't have, it's good. It's a good exercise to do to, I guess, make sure that the asphalt pavement design is designed properly. And I just wanted to make sure that everybody was aware of that. That wraps up the slides that I had for today. I want to thank you for your attention. I want to pass the ball to Mike Ward of Rabine Paving, and he's going to talk about some asphalt maintenance activities that would be necessary to make an asphalt pavement last as long as you hopefully would want it to. Thanks again.
Mike Ward, we can see you.
Can you hear me now?
You're all good.
All right. Sorry about that. Having some technical difficulties here. So, getting back to where I was following up with, we do a lot of work for a lot of big box stores all across the United States. I think that in following up with what Mike was saying, which was a great presentation, the key to any pavement design based on the customer's need is going to be making sure that the pavement is designed correctly. I think that today, more along the lines from a contractor standpoint, what we see is a lot of cut and paste of specifications. And at the end of the day, most contractors are just forced to build what's on paper. So we really try to work with our customers, understand what their needs are, and then from there, try to build the exact pavement that works best for the application. Sometimes that's concrete, sometimes that's asphalt. So what Theron asked me to do was really try to focus and give a quick breakdown on the life cycle cost analysis on what we see with asphalt pavements. But again, just circling back, everything is going to be based on the design and understanding what the customer's needs are. So a couple little tidbits here. Obviously, we've got quite a few different awards. We've been in business for over 45 years. So, you know, that in itself, obviously, we've started to add different things. We started off primarily as an asphalt pavement contractor and have ventured over into the world of concrete pavements. So we really want to talk about more along the lines of industrial or warehouse asphalt pavements. So I just put into context, typical large scale project is going to be about 100,000 square feet. As Mike alluded to earlier, you're going to see anywhere between 30 to 100 loaded and unloaded semis a day. One of the main things I think that what we've learned in the last few years is that actually it's not the loaded trucks, but the unloaded trucks that cause more damage to the pavement. But keeping in mind, no matter what you're doing, asphalt or concrete, you want to make sure that the pavement is designed properly. So doing as much research up front to figure out the number of trucks that are going to be traveling across the pavement, making sure the correct mix designs are used. Asphalt pavements, I think in the Midwest region, are predominantly sharing most of the market. They're built generally faster. They have a faster return to service as opposed to waiting for the concrete curing. They're a little bit more flexible, I think, with taking on the temperature fluctuations, freeze-thaw cycles. Generally in our market in the Midwest, we see that your typical asphalt design is going to be a 6-inch asphalt. A lot of times that will be reduced down to a 5-inch for budgets. But generally for a 100,000 square foot parking lot that we want to last 20 years, we're going to design a 6-inch asphalt pavement over generally 10 inches of aggregate base. That's going to be 2 layers of 2 inches of 4-inch bituminous binder to get you a total of 4 inches for base course, 2-inch wearing course, surface course. Parking lots are investments, so just like a building, they have to be maintained. So what affects the pavement life cycle? How long? Oh, getting carried away here again. How long the pavement will fulfill its purpose depends largely on the initial construction. So starting with the design and then obviously the installation. Every design is unique to the location, the area, the usage of the lot itself, the traffic patterns. Starting template for approved design, each design needs to factor in outside impacts specific to the location and facility operating needs. I know on our end, we try to, in any tight quarters where we have a lot of turning trucks, high traffic and unloading areas, we would look to utilize a concrete pavement as opposed to an asphalt pavement, just for the wearability factor. Design should include sufficient base support and the proper asphalt depth. The entire structure would be at risk for early failures if it's not designed properly and we're putting the heavy trucks across those areas. Turning and parking, as I discussed, such as trailers on the surface, the moisture and liquids in the pavement could be exposed to. If we don't have good drainage and we can't get the water to cross, we're going to have pooling. Pooling will then force freeze thaw cycles to take place, which will have early and or just increase the amount of maintenance that would be required on the site. So how long will that parking lot last? Well, we're looking to design for this context a 20-year pavement. So we definitely want to make sure that we use the proper base course. You'll typically see on an industrial parking lot like this, I believe we can get 15 to 20 years out of that pavement design. If we're doing asphalt pulverization, where we're intermixing the existing aggregate base into the old pavements, I think we see a little bit less of a life cycle on that. Especially on the heavy duty pavements, you increase the amount of deflection that we see. Asphalt overlays, generally, as long as the base is intact, then will last an additional 8 to 12 years. Just a tidbit to throw in there, we try to figure 30 to 40% of the total surface area requires substantial removal, just for bringing in the right size equipment and doing the patches, also to make sure that the area is just beyond or outside of the damaged sections. Generally, you'll see with asphalt pavements that the base work or the base materials that are left will also have some damage. So once we get to 30 to 40%, we're looking to do a full resurface. But in this case, we would be looking at much further down the line, as opposed to around the 15-year mark, which we'll get to in a second. So the 5 stages of an asphalt pavement. Stage 1 obviously is a new pavement. We generally would prefer to that in a 1 to 5 year category. During that 1 to 5 years, we're going to see some general maintenance. Stage 2 is the preventative maintenance stage, especially in the Midwest. That's where we're going to be looking at doing some crack sealing, potentially seal coating. Generally, you're looking at some restriping. In a 5 to 7 year period on these types of pavements, we wouldn't expect that we're going to be doing much repairs in a 5 to 7 year window. Stage 3 would be minor repairs, years 7 through 15. We're going to get a little bit more, probably crack sealing. We'll have some deflection that shows up in the surface of the pavement. We'll be looking for, again, at that point, you can do a refresh of seal coating. You're probably going to start to see some minor pothole repairs, things along the lines of that, maybe some seam rutting, shoving in the 7 to 15 year period. Stage 4, major repairs. Major repairs, we're probably going to be coming in, doing some full depth remove and replacement. This could be right at the seam edges of hitting concrete aprons. It could be the aprons coming into the facility, heavy turning radius sections. So larger wear and tear sections, and depending on the level of maintenance that the project receives in the initial stages is going to lead to what that is. And then obviously stage 5, we're looking at complete reconstruction. That's a little bit, I guess, to interpretation. A lot of times if the base layer is still intact and we're doing all of our general maintenance, we could get really lucky and we don't need to remove the entire base section, and we could generally we'd be looking at some patching and then a 2-inch mill and overlay in the final stage. So new pavement, obviously it goes in, it looks nice and clean, black, fancy striping. It's nice and smooth, pedestrian traffic, car, truck traffic. This obviously will save the facilities a lot of money, reduce wear and tear on vehicles. It has a general clean look and appearance, and that will generally last up to 5 years. It should require very little maintenance. Seal coating is kind of along the lines of interpretation. We generally recommend structurally, from a structural standpoint, you're going to seal the application twice. And then after that, it's basically up for whenever you want to make the property look new and clean. Stage 2, like we talked about earlier, we're going to get in, we're going to start to see more freeze thaw movements. We could see some deterioration around asphalt seams, cold seams, construction joints. So generally we'll see hot tar crack sealing at those areas. Our goal is to get in, open up those sections so that they will receive the joint sealer, much like a concrete pavement. The goal is obviously to seal off all those joints, keep the water out of the subgrade and the subbase, which then in the winters is where we start to see most of our damage on our pavements. Again, seal coating, this should be done anytime after the first 6 months to the first year. And then we generally recommend after the first sealing, 2 to 3 years. After that, it's strictly for appearance. In the Midwest, there's forms of maintenance that are important due to harsh winters. The rapid climate variations paired with snow that creates freeze-thaw cycle. So basically those preventative maintenance measures will elongate the life cycle of the pavement as long as you're doing the base remediation. At the end of stage 3, we're going to start to see where we're doing some patching, so minimal patching, potholes, structure adjustments, cracking, seam raveling. We obviously do both pavements again, as I referred to earlier. In the last few years, I think we've had a break with the number of structure repairs that we've been called out to do in the winter on both concrete and asphalt pavements. But about 2018, I think we did 180 through the winter. That was grinding down high spots and putting back together damaged structure, drain structures from freeze thaw cycles. This year, we hit another big freeze thaw section through early January, and we were right back doing the same thing again. So very important to keep the water out of those pavements. That's generally where we'll see most of the work in that early stage. So again, we talked about the second coat of the seal coating is usually done in stage 3. And that should seal off all of the remaining pores in the asphalt that we're looking to keep all of the oils in the mix and keep that mix flexible instead of drying out. And that's obviously one of the goals, to keep that pavement lasting a long time. Most of the time on these patches, they're going to be small patches. We're going to saw cut, remove, replace. We're looking to get a clean joint. And again, we want to keep the water out. Stage 4, major repairs. Years 10 through 20, again, depending on, just like with anything else, the maintenance that you do on your properties in the beginning is what's going to give you the overall life cycle. There's no difference with that. If you neglect the pavement, whether it's concrete or asphalt, you're going to have more problems long term. So in this stage, we're going to start to see areas that we talked about earlier, heavy traffic areas, sitting areas where we have water, things like that. We're going to have to probably come in and do a little bit more than a general patch. So again, we're trying to address the potholes, block cracking, alligator cracking. Usually in this instance, we're able to get away with doing the top layer and replacing it. So that would be it. In this picture, we're obviously using a mill. We're removing 2 inches of the asphalt pavement, put back 2 inches of the surface. And that will give you basically a parking lot that's looking new. Water and ice in this world are 2 of the most destructive elements to pavements. And obviously they can turn small cracks into potholes very quickly. Stage 5, complete reconstruction, would be the last stage, years 15 through 20. And that's usually when the surface is complete disrepair. Removal and full replacement could be necessary of the pavement areas. If the sub-base was installed correctly and we're keeping the water where it should be, running across the surface, and it's not in the ground, generally we shouldn't have to be repairing the subgrade again. But due to repeated temperature changes, freeze thaw in the Midwest, these definitely are in that 15 to 20 year period. You're going to have some larger patching that you're most likely going to have to do. When this happens, the old asphalt's removed, the parking lot's completely regraded, compacted, and then you're starting back over with anywhere between a 5-inch and a 6-inch asphalt pavement. Proper maintenance, assessments, repairs are essential in sustaining pavement life cycles. As we mentioned earlier, asphalt patching and drive lanes and corrective measures around storm structures will obviously prolong the life cycle of the asphalt pavement. Alluding to what we started with earlier, the warehouse lots, or any of the larger lots, if we generally want to say 100,000 square foot or more, the asphalt, the 6-inch pavement, 10 inches of base, is going to give you a properly designed pavement for the truck traffic. So when we talk about the cost that we look at for an asphalt pavement, so if you were to generate a budget, and this changes a little bit through the area, I use 10 cents because I see that average in the Midwest region around here. But starting in year 2, you're going to look at a 10 cents cost per square foot for a seal coating. In year 3, you're probably going to, on a 100,000 square foot pavement, you're going to see generally around about a $1,500 cost expenditure for doing some joint sealing. Joint sealing can be anywhere between as low as 75 cents a square foot and $1.25 a linear foot. And that just goes back to, again, I would spend, and I would tell all of our customers to spend the money, that small amount of money, to obviously get the full life cycle out of their pavement. Starting in year 5, you want to plan to spend around 5 to 10% of the lot at $3 to $5 a square foot. So at the fourth phase of the pavement, generally, so a $3 to $5 is going to be your 2-inch mill and resurface, with also, that should also cover the cost of the full depth patching that could be done in some sections. Overlay and resurfaces top 1.5 to 2 inches in years 12 and beyond. So crack sealing, again, we're looking at about 85 cents a linear foot on average. Seal coating in the first couple of years at 10 cents a square foot. Asphalt patching at $3, starting in years 5 through 15. And I would tell you that you're not going to be doing patching every single year, but you could get on a cycle after year 10 where you're doing it every couple of years. So, and generally, again, $3 a square foot. Remove and replace at $4 a square foot. And those are generally along the lines of the fourth phase of pavement, years 12 to 18. We use the PCI index for all of the projects that we work on for the larger, all the larger warehouse projects. So generally when we go in to look at the pavements, we ask the customers on what their interpretation or what their expectation of their pavement is, how long they want it to be designed for, how long they want to see it perform, and then working backwards to establish budgets. But the PCI is a good tool that we found to work to be able to better generate and understand the client's expectation and then the cost for budget. A lot of the things that the PCI index uses, especially on asphalt, it'll register points for bleeding, block cracking, bumps and sags in the pavement, alligator cracking, depressions or pothole areas that hold water, edge cracking, joint reflection, lane and shoulder drop off, which again, something to address, should be designed properly, but as long as the water drains off, then the pavement's going to work on a much better level. Longitudinal and transverse cracking, low ride quality, patching and utility cut patching, polished aggregates. You'll start to, on a high traffic area, you'll start to see the surface get honed down. So generally in the winter or in rainy times, you'll have a little bit more of a slippery pavement. Potholes, again, rutting. Generally we'll see those in areas where maybe at a guard gate or a sitting area where the trucks have a large frequency of start and stops. Slippage cracking would be unbonded pavement, swelling, and then weathered or raveling asphalt, which is just going to happen through time. So those are generally, it's just a really good way, a good tool to utilize to be able to design the right pavement and make sure that the pavement that you installed is performing at the expectation that it was bid for. So hopefully, as I stumbled through this presentation, you guys learned a little bit about asphalt and the differences in between how that's going to be constructed over your concrete pavements. And again, I think the goal is to, either way, whether you're performing asphalt pavement or performing a concrete pavement, design is going to be huge, and then understanding the client's expectation. So thank you for your time. Thank you to Illinois and Ohio Ready Mix Associations and Darren Kowalski for having me on today. Would love to answer any additional questions if you guys get them out there. So with that, I'm going to turn it back over.
Thanks, Mike. Great job on your presentation, both Mikes. We're going to start reviewing some of these questions. We had a lot of questions come in. The first question is to either Mike. Is a 2-inch minimum recommended thickness for a surface course?
I would only say that in this application, dollar for dollar, you would be better off to spend to get the extra ½ inch for the life analysis, I think, over the ½ inch in cost.
Yeah, what Mike Ward's saying, it does somewhat matter on the aggregate gradation that you're going to select for that surface mix and the appropriate thickness then for the layer thickness that would come from that. An 1.5 inch upwards of 2 inches are typical surface lift thicknesses. A 2-inch surface, I think, is better than 1.5 inches. But if you've got an 1.5 inch lift because of the materials that you have available, that's not the end of the world.
Okay. Thanks, Mike and Mike. Next question is, does Mike Harrell agree that 3 inches on 8-inch asphalt design is an adequate design for light-duty commercial pavements that'll also have a trash truck collection service?
I would make sure that we ran through the design process to make sure that that actually would hold up, because we would want to know the frequency of those trash collections and also the typical weight associated with that truck and the axle loading. I don't believe in really just pulling a design off of a shelf. I would like to see that that site is designed specifically for that purpose. 3/8 is fine for automobile traffic, but if you're going to have any trucks really on it, I would want to make sure that that's going to hold up.
Okay. This is another one from Mike Harrell. For industrial pavements, you mentioned a minimum of 6-inch aggregate base. Is there a minimum recommended asphalt thickness when optimizing total pavement section thicknesses that you would not go less than? Is there a minimum design?
That's a good question, and I would again point back to the design process to come up with the layer thicknesses that are appropriate for a facility. I personally would not want to see an asphalt really thinner than 4 inches of total material for any industrial type application, and even then, that would not carry very many trucks. So I really would want to run through the design process, but a 2-lift, 2-inch binder, 2-inch surface would be the very bare minimum that I would expect to see.
Okay. Another question, do or should engineers inform owners that the follow-on periodic maintenance should be expected and factored into the total cost of the pavement? This is for both Mikes.
Well, I'll start. I'd say that, yeah, if you're producing a report that has the design procedure and the ultimate, recommended thickness design for a facility, that there should absolutely be some sort of statement in there that says that, a pavement doesn't just last forever without being maintained properly, that there is an expectation besides that structural design that proper maintenance activities are performed at a regular interval. No different than if you're going to maintain your car. If you're going to change the oil in your car and make it last longer, you're basically doing the same thing to make that pavement last the way and the length of time that you expect.
Mike Ward, do you want to comment on that?
Yeah, I'll answer real quick. I think that what we have seen is that most of the companies now are using either engineering reports or they have programs that they've designed. So they do. There's this has come a long way, I think, in the last 5 years. So the overall answer is yes. I believe that most of our customers or most of anyone designing these parking lots know and understand that there's going to be some additional follow-up. I don't know that every single company budgets correctly for it, or you might budget for it, but then you have to spend budget money separately. So I think overall, yes, the industry is educated enough to know that we are, that you're going to need to do additional maintenance with asphalt pavement. But I don't know that they keep that in mind 100%.
Okay. Here's another question. It says, how much are you seeing fibers being added to both asphalt and concrete to reduce section thickness?
I'll go real quick. I I've seen certain customers or certain clients, they install it or they have it set up in their program so that they can have the option on what they want to do. One of the hardest things, in fact, I was talking with you earlier, we were having an issue on a project that we're on, trying to get the asphalt plants. Asphalt plants are very negative with introducing fibers into the asphalt pavements. And when they do, there's also a different degree of what you need to do to get compaction, to get your strength and your density out of your asphalt mixes. So overall on the question, yes, we're seeing it more and more, but I don't see it to where it's going to be an everyday use.
Mike Carroll, you want to comment on that?
Just to add really to what Mike said, I thought he handled that pretty well. We are seeing some more interest in introduction of fibers into asphalt mixtures. The design procedures, I think, are lagging the material development. So the fiber folks have come up with some pretty great product, but the widely used pavement design material modeling and software are not yet all ready to accommodate the changes in engineering properties and for those materials associated with the inclusion of fiber. So it really does put the engineer at a tough spot, because we recognize that there is an improvement in performance with that material, but the question is just how much, you know. And if you're not able to model it, it's really challenging to say that I'm going to reduce my thickness accordingly because I'm including these fibers, when you don't know for sure that you're going to get that commensurate amount of improvement in the material properties. So from a design perspective, we're in a weird place right now, and I think that we're getting better design tools every day to help take into account the better properties from those materials and be able to reflect that in thinner layer thicknesses.
Okay. Another question we have, got some good questions. We're going to keep going. It says, I've had some clients ask about recycled asphalt or recycled concrete for a base course. Is that a good or bad idea?
I'll start. Those materials can be very effective if they're, I'd say, sized properly and crushed to the point where they're able to be compacted effectively and get that stiffness back out of those materials. So that can be effective.
Okay. Mike Ward, did you want to chime in?
Yeah, I would just say, no, I would agree completely. I think the different goal with asphalt is we want to make sure with recycled asphalt pavement that we get it intermixed with the aggregate base course, so that we don't have any issues with the liquids heating back up underneath pavements. The only time that I think that you ever really see an issue with that is on sitting on hot days, like you referred to with the why would it be why is it important with summer school? Asphalt, pliable material, hot days, sitting trucks, so you just generate a lot of heat in those areas. You could get a small pocket, but as long as you pulverize and mix the material thoroughly, it's a great resource to recycle.
Great answers, guys. What is your suggestion to use for loads for a pickup truck versus SUV compared to a standard vehicle loading?
All of those vehicles really fit into an automobile classification, unless you're talking about a dually, a pickup that's actually intended for like industrial commercial purposes. So there's no difference in the modeling for a regular passenger vehicle as a pickup and an SUV. Those are slightly heavier than an automobile, but really the automobile that was modeled, when thinking about asphalt pavement design way back in the day, were these gigantic, huge sedans. So the standard regular vehicle weight has come down to the point where now an SUV is about the same weight as that old car was. So I don't know that there's a whole lot of difference there. You really just have to watch out for whether or not a truck's being used for commercial purposes and having a lot more loading associated with that.
Okay. It says Mike showed an asphalt design of 20 years. However, he called for stage 5 complete removal and replacement in years 15 to 20. Can you explain how a 20-year design needs complete replacement in only 15 to 20 years?
I think that what I was alluding to is there's always the chance that with that pavement, if its design will be for 20 years. Overall, if the property or the pavement is not maintained, which we see a lot of times, you'll see it's not designed correctly. And when you go in and you put down a 4-inch asphalt pavement, that's generally when we see the failure come in that earlier time frame. So when I put all of our slides together, when you had asked me, you said, what would we do for an industrial pavement? On an industrial pavement, a 6-inch over 10-inch aggregate, I would expect that to last the full 20-year cycle. If you are forced to build something a little bit smaller, a 4-inch pavement or a 5-inch pavement, then I would look to insert with no maintenance or little maintenance. I would look to have complete replacement in that stage 4 to 5 section.
Okay, and I think this might have been a typo. I think it was a 15-year design. How is a 15-year design not being fully replaced till years 15 to 20? I think that was what the question was supposed to be. Does that make sense, Mike? Mike Ward? Yeah,
I would go back and look. I mean, I think we see 15, 20-year pavement designs. I see 10-year asphalt pavement designs last 20 years. Again, it's, based on traffic use. One of the big things that we've been talking about is a lot of lighter duty asphalt pavements will handle car traffic all day long. We do a lot of HOA projects where the garbage trucks come in twice a week. Unfortunately, they drive through the entire complex to get to the garbage area, and then that leaves a heavily loaded truck running on a pavement that was designed for cars, and you see damage through the complex that then only compounds. So it literally, but that could be on the basis of talking about an industrial pavement. I would say that a 6-inch asphalt pavement over 10 inches of aggregate base for an industrial will get you the full 20-year life expectancy.
But with that being said, with all the proper maintenance through stages 1 through 20.
Absolutely.
All right, next question. Does the design software that Mike Harold demonstrated take into consideration the use of GeoGrid for increased strength in the subgrade? Additionally, can the design software take into account chemically modified subgrades without the need to adjust the coefficient for the subgrade layer?
So there's a 2-part question there. And the first part is it doesn't directly allow for the placement of a GeoGrid, but it does allow you to change the engineering properties associated with that subgrade. So if it's reinforced with a grid, you could expect that you've got a better or a stiffer modulus to respond to loading, and therefore you can use that increased modulus value in the design process. The chemically modified question is actually a very similar one, and it really just would affect the resilient modulus of the subgrade material to say that it was stiffer. And usually with a stiffer subgrade, you'll see a reduction in the requirement for other paving materials on top of that to protect that subgrade.
Is there a belief that the coefficients recognized by most state DOTs are a bit conservative?
I would say yes, that is a pretty commonly held belief. The state the coefficients, layer coefficients that are in place in some state pavement design guidance are usually conservative. They've done some lab testing to try to reverse engineer what a layer coefficient would look like. There's been a lot of research done primarily at NCAT at Auburn University to investigate layer coefficient performance and expectation. They've seen layer coefficients for asphalt materials to be 0.5 or higher, depending on the quality of that material and when it's placed, and the quality of the construction of that material. So all of those variables matter in how that material is going to perform. So it's really about how much you assume that it is going to actually do the things that you want it to do, and how much risk you're willing to take. DOTs as a group tend to be fairly risk averse, and so they will insert some conservatism in the assignment of that layer coefficient, so it does provide some factor of safety if compaction isn't reached, or air voids aren't on target, or the subgrade is still wet for some reason. That there's a bunch of factors that you can overcome by being a bit conservative with those layer coefficients. They are supposed to be reflective of the actual engineering properties of each material, and there's separate places in the design procedure to insert variability or expected amounts of variability. But ultimately, yes, I think that they found those to be a bit conservative.
We're going to take two more questions and then wrap this up. I appreciate everybody staying on. Pave Express uses AASHTO 93. Are MS1 and IS 91 no longer appropriate?
I assume that one's headed towards me, and I got to be honest with you guys, I'm not aware of MS1 and IS 91. So if those are design procedures, they would have predated the AASHTO 93 procedure in terms of a national standard. And really, AASHTO 93 is being phased out itself, as I led off with my presentation, that there's a movement. Most states have moved to mechanistic design process, but that's at the state level. We're seeing, a movement that direction for locals as well. But the software to perform that is a little more rigorous and complex, so it does take some more training and expertise.
All right, last question. With higher structural numbers, is there a good rule of thumb for ratios between the thickness of the varying asphalt layers?
No, that one's more of I'd say a cost benefit analysis. And because if you can get a binder course at, with a layer coefficient of 0.36 to have a, maybe 20% less cost than a surface course, you may find that you can get the structural number that you need with more binder material than surface material, and ultimately save or have a more cost efficient structural pavement design. Surface materials are typically limited to the surface because they're typically the most expensive, and the majority of the asphalt structure is made up with the larger aggregate material to help build that foundation. So, but no, I don't have a real good rule of thumb for ratios there, just because we don't know how much binder material ultimately you might need.
All right, thanks, Mike. Mike, with that, we're going to wrap it up. I have a couple closing announcements. Again, the Illinois Ready Mix Concrete Association and Ohio Concrete would like to thank everybody who attended the webinar today. The PDH credits will be to you in the next 7 to 10 days. The Illinois Ready Mix Concrete Association does have a lot of sponsors that sponsor these webinars. If you go to www.irmca.org, all these sponsors, or most of them, have put links to different information you might want to read on different technologies that the concrete industry is using, and that you as an engineer can specify and use. And with that, our next webinar will be on April 7th at 12 p.m. Central Standard Time. It is on how specifying carbon cure in your parking lot concrete can lower CO2 emissions. We have two speakers, Ellison Palmer, with Market Development Manager for Carbon Cure Technologies, Ryan Ciadella, Vice President of Customer Development with Ozinga. They will both be presenting. Registration will be open on Monday, March 29th. And again, Illinois Ready Mix just got on social media not too long ago. We're on LinkedIn, Facebook, and Instagram. Please follow us. We post a lot of information on these webinars, and then just useful new technologies, new types of concrete pavement systems that we're out promoting to the industry. Again, I'd like to thank everybody for attending today. I hope you enjoyed the webinar.